All right, let's dive right into this explainer. We're going to look at the massive, completely invisible infrastructure shift that magically eliminated the dreaded buffering wheel of death. Seriously, think about your daily routine for a second. We consume media all day, every day, right? And we just expect it to be flawless, instant, and high definition. But it wasn't always like this. Today, we're exploring the unsung hero of our digital infrastructure. This is the system quietly operating behind the scenes, making sure the physical limitations of our world don't totally ruin your streaming experience. It's an absolutely brilliant piece of engineering, and by the end of this, you'll know exactly how it pulls this off.
I mean, really think back to the dark ages of the internet. For those of us who lived through it, you know the drill. You'd click a video and just sit there. You'd stare at that spinning loading wheel for 3 agonizing minutes, finally get to watch maybe 10 seconds of totally pixelated, blocky footage, and then, boom, you hit another buffering wall. It was literally a test of patience. But today, you can pull out your phone while bumping along on a crowded city bus and seamlessly stream a 4K movie. It genuinely feels like magic. But it's not magic. It's the result of one of the most massive shifts in human history in how we handle data. Section 1, Physics of the Internet and the Speed of Light Problem. To understand how we actually solve this, we first have to meet the ultimate villain of our story. You see, the fundamental bottleneck of the internet isn't really a software issue, it's a physics issue. Picture a popular creator uploading a brand new 4K video. That file doesn't just float around in some magical weightless cloud. It is physically stored on a massive hard drive in a primary location, which engineers call an origin server. Let's say that origin server happens to be in New York. If a viewer sitting over in London wants to watch that video, their request literally has to travel across the Atlantic Ocean, navigate through deep-sea fiber optic cables, hit New York, grab that massive video file, and drag it all the way back to London. So the crucial point here is that while data is incredibly fast, crossing entire oceans still causes latency. And latency is simply the lag created by physical distance. Look, even though our data is traveling at speeds near the speed of light through those fiber optic cables, a trip across the Atlantic takes time, period. And when you're dealing with massive 4K video files, that time really adds up. Distance creates lag. There is simply no getting around the laws of physics. Now, take that problem and multiply it. Imagine a video goes viral, and suddenly 100,000 people in London ask that exact same New York server for the file at the exact same time. The system gets instantly overwhelmed. Those deep-sea cables would have their bandwidth completely choked, and every single one of those 100,000 viewers in London would be stuck staring at a buffering wheel. Nightmare, right? Section 2, living on the edge, building the solution. Engineers quickly realized they couldn't just build bigger servers in New York. They needed an entirely new approach. If physics dictates the distance causes lag, well, the only logical solution is to eliminate the distance. Enter the Content Delivery Network, or CDN. Instead of relying on one giant central origin server that just gets crushed by global traffic, a CDN is a highly distributed global network of proxy servers. Think of them as digital middlemen scattered across hundreds of cities worldwide. This was a total game changer. The entire architectural strategy of the internet literally shifted from centralized power to decentralized distribution. By placing these smaller servers literally on the edge of the network, as close to the end user as physically possible, the CDN bypasses that terrifying ocean journey entirely. When engineers talk about the edge, they mean placing the data exactly where the people are. The whole goal is to get that massive 4K video file as physically close to your phone or your living room TV as humanly possible, so we don't have to repeatedly cross the Atlantic. Section 3, the millisecond handoff, CDN magic in real time. We know what a CDN is in theory, but how does it actually pull this off when a video goes live? Well, the CDN uses this genius 4-step sequence to manage traffic. It breaks down into the upload, the first request, the cache, and finally, the instant replay. Understanding these 4 distinct steps is absolutely the key to understanding why your videos no longer buffer. Okay, so for the very first person in London who clicks a new upload, they actually do have to wait for the data to travel across the ocean. When the creator uploads the video to New York, the original file stays right there. So when that very first viewer in London hits play, their request has to cross the deep-sea cables all the way to New York. The data travels back across the ocean, and because of that massive physical distance, this first viewer takes the hit. They might actually see their video buffer for a split second, But here is where the magic happens. As that data flows through to the first viewer, the London Edge server recognizes the file and quietly saves a local copy. This is what we call a cache. That CDN proxy server sitting in London acts kind of like a highly intelligent toll booth. It watches this heavy 4K video file pass through from New York on its way to the first viewer, identifies it as a popular piece of content, and immediately duplicates it right there in London. So, by the time the second person in London clicks that same video, we get the instant replay. Their request never goes to New York. The London Edge server intercepts the request and enthusiastically steps in, basically saying, wait, I already have a copy of this. It hands the video over instantly, which completely protects the New York origin server from getting overwhelmed. The difference this makes is just staggering. Instead of 100,000 requests crossing an ocean and choking the bandwidth of those deep-sea cables, those requests are handled locally. They're pulling from a server that might just be sitting in a data center a few miles down the road from your house. The physics problem wasn't broken, it was just ingeniously bypassed by shrinking the distance the data has to travel. Latency drops to near zero.
So we conquered the physical distance of the globe using content delivery networks, transforming an internet of spinning, buffering wheels into the seamless, real-time experience we all take for granted today. But as our hunger for data continues to grow every single day, it leaves us with one pretty massive question. Now that distance is no longer a bottleneck, what massive, invisible infrastructure will we have to build next?